we are going to do is we will create a folder. This is going to be the workspace for us. We will do apt update to update our system. We will install some tools that we need, like curl, and then we will basically install ROS. We will need to include the source to download the ROS with the Git. Once we have that, we just install ROS Foxy base. Okay, we source the system, and then we also download the Webots ROS2 interface. So here is the actual command: git clone. You may notice that this is not the official Webots account. I will briefly talk later on about this, but basically I modified the package for the Webots 2 to work properly. So this is just a fork from my own Git repository. We are downloading this, and we are compiling the workspace with the code build, and then we will just source everything back. So hopefully I answer the question to our audience. And also we include this little command for the container to never die, so we can play around with it.
I think this was a good explanation. Thank you, Adrian.
Perfect. Okay, so we were trying to figure out how to know the IP of our container. Well, in this case, our pod. So what we are going to do, we have this in the instructions, but what we are going to do is basically we will connect to the container by using the command that we used before. It is this one. Okay, just need to change the container ID to the actual container ID. And once we are here, as Bartosz has already showed to us before, we will do if config inside the pod, and we will get the IP. So in this case, this is the IP. Okay, so we connect to our simulation, but now we want to do something with our simulation. Okay, I can display it, I can see it, but let me play with the robot. So to do this, we have to install, and this is not included in the YAM file. We will install some teleop twist keyboard package to move the robot around. So here is the command to install it. I have already done so, but here basically we have sudo apt install ROS Foxy and the teleop package to move the robot around. So let's just paste it here. It will tell me that this is already installed. Yeah, 0 upgrades, 0 new restarts, and so on. And to run the package, we will just do ROS2 run, the name of the package, and the name of the executable. So let's clear up. Let's paste it. And this is a very simple teleop program. It is also in ROS1. So what we have is we go to our simulation here. We open up our terminal. Let me zoom out a little bit so you can see the robot moving perfectly. And if we play with the controller, we'll be able to see how the robot moves around. Yeah, it does whatever it needs to do, like go to some corner or something else. There is a little bit of lag, but yeah, we can access everything from the ROS console, get all the topics, move the robot around. So this is an interesting way of how we can deploy a containerized simulation within the Kubernetes to give it to the OSM to deploy it automatically. So the robot itself doesn't need to run the simulation internally. So we'll have some more resources for the robot available. So this is it for this demonstration. We will now be having a 5 to 10 minutes break. So yeah, ask any questions in the chat, take some coffee, and we will be back in the 5 to 10 minutes. Okay. Thank you very much.
Great. So let's say we will resume at 11:15 in the UK, 12:15 in the continent. So we will resume after we have coffee. There is a question from Jakob about after the image is downloaded, it's empty without, I guess take some time. Maybe you can explain that.
Are we talking about the Weebots
Yeah.
image?
Yeah.
So when you download this, it will be empty because the Kubernetes is installing everything. So when you run, let me actually go back to the screen once again, very, very fast. So in order for this to work, what you need to do is, after running this command to launch the experiment, wait around 5 to 10 minutes for the container to install everything. If you come back after 5 to 10 minutes, you will see that there is already, let me actually show it to you. You will be able to see everything. Like, for example, there is the OPT ROS, and there is also the workspace. So basically, just give time, because the container is doing this in the background, and you cannot see it immediately what the container is doing. This is misleading, because if we exit the Kubernetes and we visualize what is happening, it will always tell you, unless something goes wrong, that the container is running, and you may be thinking that the image is already ready to use. However, the status running is switched on the moment the image is downloaded, but only this image. So the Kubernetes needs to do this. So yeah, wait 5 minutes and it will include everything back. Hopefully I answered the question. Please let me know if you get everything after 5 minutes.
And there's a good question, Adrian. How do we get the sensor feedbacks from the robot into the Kubernetes? Do you know how can we?
Yeah, so we are talking.
Taiwo asked how do we get the sensor feedbacks from the robot into the Kubernetes?
Okay, so let me share the screen back. So as we were saying before, we are running the simulation in a container, but we also have the ROS installed inside it. So the thing is that we can do this ROS to topic, and maybe I need to source it. Oh, I am not in my, I'm not in the pod. Give me 1 second. So ROS to topic list. There is a package that is called Weebots ROS2. So this is the package that actually communicates the Weebots with the ROS system. So wherever you have installed your ROS2 system, as long as you have this package running, you will be able to get all the data from the robot. And because this package is being run, we can actually access the topics of the robot. So if we want to access the odometry data, we will just need to ROS2 topic echo, and we will do odom. And the robot is not moving, so you will get 0 all the time. But yes, so now you can access the data and you can write any Python file or any C++ file within the ROS framework, and you can subscribe to this data and do anything with it. Also, another thing that may be interesting for you guys is that this pod we are connecting is the one from the simulation. So you may be wondering, can we do another pod and get the information from the other pod? And the answer is yes, we can do this with the Multus. So before we were talking about the Multus and how you can configure a network within the Kubernetes. So let me show you an example here. Yes, so we are defining in this YAML recipe a network of the Kubernetes. And what we are telling is that the Weebots will enroll into this network. Okay, I don't think yes. So these are the 2 commands that tell, okay, this pod is going to enroll in this Kubernetes network. So if we add any other pod, I think I have it somewhere, maybe this one. Yeah, so for example, in here, you have an example of creating a Kubernetes network, and there is two pods. There is a listener and there is a talker. So these two connect to the network created by the Kubernetes, and if all of them have installed ROS, they can communicate. So this is what Bartosz was showing us before. It is a simple demonstration of a talker and listening in different containers, talking through each other with the network. So I think
yes, that's right.
That's the. Hopefully, I answered the question.
We got a lot of interesting questions, and I think we will resume the demonstration in 2 minutes time. And what should we do next? Should we back to Bartosz for his part, or should we continue for the program test? What is your plan?
Adrian, how long it will take for you to build the rest of this image and follow?
I am only planning to showcase the Apex AI demonstration, so it should be straightforward.
Okay, so maybe let's continue with your part, and after this we'll go back very quickly for like I mean the most 5 minutes most to finish the micro case deployment. So we will be able to explain this in more detail on how does it work.
Okay, then let's have a rest for 5 to 10 minutes, and we will come back.
1 minute.
1 minute.
1 minute, Adrian.
Come on.
It took us a bit of time on the questions, but I think
it's good question.
Yeah,
also interesting things.
Yeah, really good questions. Okay, Adrian, should we start? Or do you want another a minute or two?
Yeah, we can start, no problem.
Okay, let's start.
Okay, so coming back, I will share my screen and walk everyone through the next demonstration that we are going to do. So very quickly, coming back to the Weebot simulation, in the Git repo that you have, there is extra information for you to have. So I posted here the official Weebot website. There is a lot of information here, and also the Weebot's to ROS2 interface. It's a Git repo for you to look in here. Okay, so now moving on to the performance testing, and this is a very specific demonstration for our networking partners, for them to have some good data to train their machine learning models with data captured by the performance tools using the ROS2. So what kind of data are we going to capture, and what kind of metrics are we going to measure when it comes to ROS2? Well, basically, what we will be getting at is this is a file, and this is uploaded in the repo of what you will be getting after running a test with Apex AI. So here you have a lot of metrics of ROS2 communication between one subscriber and one publisher with a specific running configuration. What is this configuration? The configuration that we are running to obtain this test over here is this one, okay? What do we have here? We are running DDS technology, which is the fast RTPS. This is the fast DDS technology that is used by default in ROS Foxy. And what we are doing is we will create a data type of array1k to be published. And also, we are going to output the result